Hi everybody, here we're going to go over the lecture for the gravity lab. And a gravity lab involves something called a pendulum. And what a pendulum is that you have a post, and to that post you tie a string, and the string is going to have a length L. And what you're going to do is, in this experiment, is you're going to displace the pendulum. Well, also, let's see what else here. There's going to be a mass tied to the pendulum, but actually mass is not going to be a factor, so I'm just going to ignore that. So what you're going to do is you're going to take this pendulum and you're going to displace it by some angle, and that angle is going to be theta. And then once you let it go, it's going to start to move around. And the reason that it moves around is that there's gravity exerting a downwards force on it, and that's going to make the pendulum cycle back and forth. So those are going to be the main component. Well, actually, there's one more. So once you let this pendulum go, gravity is going to, so let's start from here. So you're going to start with the pendulum, then at this position, and then when you let it go, the pendulum is going to swing. It's going to go to some maximum value here, and it's going to come back to the original position. So this time for the pendulum to make one cycle, that's called a period. And the period is going to have a variable capital T. So today what you're going to do is there's going to be two main parts to the experiment, but the main terms are going to be the length of the pendulum, the angle that you displace the pendulum by, and also the period that it takes, which is the time for the pendulum to make one full cycle. And the purpose of today's lab is to measure these values in order to get an experimental value for gravity. So let's go ahead and take a look at what you're going to do for part one of today's lab. So for part one, you have your, well, for part one, what's going to happen is that the length is going to stay constant, and you're going to change the angle. So for part one, length is going to be constant, and you're going to vary the angle, and from that you're going to measure the time. So let's see how that's going to work. So we have your pendulum. I'm going to ignore the post. So let's say that this is the support system here, and the pendulum is going to have a length L. That length is going to stay constant, and what you're going to do is displace the pendulum by some angle theta, and then you're going to let it go, and the pendulum is going to come back to its original place. But the thing is that this pendulum is actually going to vibrate pretty fast, so it's going to be hard for you to measure the time for the pendulum to make one full cycle. So instead, what you're going to do is you're going to displace the pendulum by some angle, and you're going to let it go, and you're going to wait for it to measure the time for it to vibrate 5 times. So 2, 3, 4, 5. So what you're going to measure is the time for the pendulum to vibrate 5 times, so for 5 cycles. And in this case, the time for the pendulum to vibrate once, or the period, is going to equal the time to vibrate 5 times, or to oscillate 5 times divided by 5. So this is how you're going to get the period for the pendulum. You're actually going to directly measure the time for the pendulum to vibrate 5 times, and then you'll calculate the period. So for part one, you're going to measure the time for the pendulum to vibrate 5 times, and so that's going to be one part of the experiment, I guess one trial. And the second trial So I'll just start from scratch here. So what you'll do is, for example, for an angle of 5 degrees, you're going to measure the time for the pendulum to vibrate 5 times, and then you're going to move it to a new angle. And now for a new angle of let's say 10 degrees, you are again going to measure the time for the pendulum to vibrate 5 times. And you're going to keep on doing that for a series of angles. So you're going to measure, so you're going to have a table, and in this table you're going to measure, you're going to be for specific angles ranging from 5 degrees, 10 degrees, all the way down to 90 degrees. You're going to measure the time for the pendulum to vibrate 5 times. And then from that, you'll be able to calculate the period. So I'll be going over that in more detail in the lecture part for the instructions. But for now, this is just a theoretical part. So for part 1, what you're going to be doing is essentially, ultimately what you want to do is to get a relationship between the angle that you displace the pendulum and the time for it to vibrate once, or the period. And so from there, what you're going to calculate, this is going to be, we're going to define this to be the experimental period, the one that you get from directly measuring the time 5 times. And you're going to compare that to a theoretical equation for the period. So this formula is a little technical, so I'm going to write it down myself here. So we're going to call, you're going to calculate a theoretical period. So I'm going to call this one T theoretical, and this is going to be for part 1. So the theoretical period, when you keep the angle, when the angle changes, so this is T theoretical. I'm just going to call it T. Space. So the period theoretical for part 1 is going to be given by this formula. It's going to equal 2 pi and then multiplied by the square root of the length of the pendulum divided by g. But there is this extra factor. The extra factor is going to be 1 and then plus, let's see here, sine squared of the actual angle, so this angle of this angle here, but it's actually going to be half the angle, sine squared of half the angle, and all of that is going to get divided by 4. But actually I'm going to write it like this. So that term, and multiplied by a factor of 1 over 4. And there's going to be another term. So then it's going to be plus another factor, and this factor is going to be 9 over 64. So really what this is an approximation, and so we're going to kind of shorten out the equation and pick just the first few terms of the approximation. And the first 3 terms that we're going to pick, and so the last term is going to be times sine, but now this is going to be sine raised to the 4th of half the angle. So for each of these angles, you're going to calculate this period. The length is going to be constant, but the angle is going to vary in each case. So for each angle, you're going to get a corresponding theoretical period. So that is actually going to complete part 1. This is just and you'll also have to calculate a percent error, but that'll be it for part 1. Part 2, the equation is simpler, but here you're going to create a graph also. So for part 2, part 1, let's summarize part 1 here. So for part 1, you had the pendulum, and you can move the pendulum over any angle, actually all the way up to 90 degrees. And there what's going to happen is that it can actually start to swing pretty wildly.